Here we have rhombus and kite. Now rhombus and kite, their areas are a little different. You don't find the area using the outside of the figure. You find the area using the diagonals, which a diagonal goes from one corner of a figure to the opposite corner, one figure to the opposite corner. This is a rhombus. Rhombus just means a figure with all sides the same length. And this is a kite. Notice it has a pair of sides the same length here and a pair of sides the same length down here. Again, its area is also determined using its diagonals, the line from one point to the opposite point. For both of them, make sure you write down the formula. The area is 1/2 times diagonal 1 times diagonal 2. So this is all multiplication. Take 1/2 or 0.5 if you prefer, and times each of the diagonals. Okay, so notice trapezoid had some addition in it. Kites and rhombus just have multiplication. Okay, so take a second, make sure you have that formula written down, maybe a picture of what a rhombus and a kite is and what the diagonals look like. With that in mind, let's go ahead and find the area of this kite. Okay, we are told that the length of diagonal 1 is 18 kilometers. The length of diagonal 2 is 6 kilometers. We know the formula because we just wrote that down. Is 1/2 times diagonal 1 times diagonal 2. Now here they gave us all the information we need. They gave us both diagonals. So we're doing 1/2 times 18 times 6. Again, if you're not comfortable with the 1/2, you can use 0.5, or you can multiply the two numbers together and divide by 2. Whichever method you use, you should get half of 108, which is 54. And again, this is area, so those would be in kilometers squared. Okay, so again, you want to have these formulas all written down somewhere so that when you need them, they are right there handy. Alright, here's another one, taking it a little further. This one's with a rhombus. It says, find diagonal 2 of the rhombus, in which diagonal 1 is 18, and the area is 90. Okay, so we have one diagonal. We are missing this other diagonal. That's a big question mark for us. We start, since they gave us the area, we start with the formula for the area of a rhombus, which is 1/2 diagonal 1 times diagonal 2. Fill in the parts we know. We know the area is 90 yards squared, so we replace area with the 90. We know we have 1/2 here. We know that diagonal 1 is 18. I'll put in an 18 there. We don't know diagonal 2. Here we start by simplifying. Let's do 1/2 of 18. They're right there together, so you can do 18 divided by 2 or 0.5 times 18. Either way, half of 18 is 9. So we have now 90 equals 9 times diagonal 2. We're solving for diagonal 2, so it's multiplied by 9. If we divide both sides by 9, we can figure out, well, what do you take times 9 to get 90? And it is 10. So diagonal 2 would be 10 yards. This one's a little more tricky. It says to find the area of the rhombus, and what they want us to review here is a little bit of algebra. Immediately when they say area of a rhombus, I write down its formula, 1/2 diagonal 1 times diagonal 2. Then I fill in the information I have. Diagonal 1, it says, is a length of x plus 2. Diagonal 2 has a length of 3y minus 2. Okay, I'm not going to get a number answer here because I have x's and y's and don't know what x and y are, so they just want a simplified version here. Now remember, when you have two things in one parenthesis and two things in the other, we have to do what's called foiling, or distribute twice. So I take the x times everything in that other set of parentheses. So I'm going to leave the 1/2 out in front here. X times 3y is a 3xy. Times the next thing, x times -2 is a -2x. Now I take the 2 times everything in the other parenthesis. 2 times 3y gives me 6y. And finally, 2 times -2 gives me -4. So far, I have 1/2 times 3xy minus 2x plus 6y minus 4. None of these are like terms, so I can't combine them. So now all I can do is go through and multiply by 1/2 each thing inside the parentheses. 3 times 1/2 is 3/2, or 1.5, minus 2 times 1/2 is just 1, so minus x, plus 6 times 1/2, 1/2 of 6 is 3y, and 4 times 1/2 is 2. So this would be, oddly enough, in the area of my rhombus. Now if they ever do tell me what x and y are equal to, I can find its actual area.